Next, let's look at the other units of measure, and this is radians. Typically in upper level mathematics courses, we tend to use radians much more than we do use degrees. So it is really important that you understand radians and you're able to work with them as seamlessly as you are with degrees. Now, the definition of radian is as follows. So 1 radian is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. Now that's really kind of confusing, but as a visual, what's happening here is you have a circle. This is called a central angle because the vertex of that angle is at the center of the circle. So that's what a central angle is. And notice that the radius and the length of that arc are all the same. So the angle that this makes is 1 radian. That's where that unit comes from. Now, realistically, you want to be able to do this for any arc length, right? You don't want to, we're using R for radius, right? You want to actually have meaning here. So we do have a formula that we can use. And this converts to the following idea. And let's say you have a circle, you have a central angle, and these rays may extend further. You don't have to be locked into just that size of the circle. It doesn't matter. But you have to have the radius and you have to have the arc length. So remember, S here is your arc length and R is your radius. And you can find the angle in radians by taking the arc length and dividing it by the radius. So it's really quite simple to do. So let's say you have just a quick example here. So in this case, my arc length is 24 inches. My radius is 8 inches, and I'm looking for my angle. So my angle would be 24 inches divided by 8 inches. Now, the units for inches cancel as well. You want to make sure you're in the same unit, of course, and you get 3, but the answer is not just 3. The units are always radians here. So 3 radians, or oftentimes you'll just see, we'll write 3 rads instead for short. So if you have the arc length and you have your radius, you can find the angle as well in radians quite quickly. Now, there is a way to convert between radians and degrees, which of course is important to know. It's good to be able to go back and forth. So a couple of good ones just to kind of know to start before we get into the actual formula is 360 degrees is the same thing as 2 pi radians. And if you think about your XY plane, what happens is your initial and terminating side would be the same. So you go all the way around the circle till you get back to your start. So that circle has 360 degrees there. I know I'm a little off center here, but you guys get the idea. And then another really important one is that 180 degrees is equal to pi radians. So in that case, you have your initial side, you have your terminating side, and you're going halfway around. So we know this one is 180 already. We saw this one earlier in a video. So this is 180 degrees, which is the same thing as pi radians. So 360, the full way around is 2 pi, and then 180 halfway around is just pi. And again, you'll get used to some common ones, right? We'll say 90 degrees is pi over 2 radians. And remember, with 90 degrees, you're doing that quarter rotation. So you're going from here to here. So 90 degrees is the same thing as pi over 2 radians. Notice here that 360 to 180 is a cut in half, right, motion. We cut this in half, we get 180. 2 pi cut in half is pi. We divide that by 2. Same thing here, 180 divided by 2 is 90. Pi divided by 2 is pi over 2. So you have that same ratio that you do have with degrees as you have with radians. All right, so now we're not going to have always just those 3 angles. Excuse me. let's give some general formulas. So if you're going from degrees to radians, what you need to do is you're just going to multiply by pi over 180. And then your units at the end will be radians. So for example, let's say I did 30 degrees. This would be 30 times pi over 180. And again, the result will be the radians. And you want to do a little bit simplifying. Obviously, 0 over 0 can cancel. And 3 and 18 are both divisible by 3. So we have 1/6 there. So we get pi over 6 radians. You could do it with negatives as well. So if I have negative 60 degrees, it'd be negative 60 times pi over 180. So here again, those zeros will cancel. These are both divisible by 6. So we have 1/3 here. So negative pi over 3 radians. We can also go the other way. Then you multiply by 180 degrees over pi radians. What happens there is the radians cancels and you're left with degrees as the final answer. So for instance, let's see, what if we did something like negative 5 pi over 3 radians. We take negative 5 pi over 3. I'll leave the units in for now. And what happens is those radians cancel for units. And in this case, the pi also cancels. So you're just left with 5 times 180. And then you're dividing that by 3. And you get 300 there altogether. And don't forget that negative. So again, we're just multiplying across here. 5 times 180 divided by 3, negative 300. Let's say I have something like 2.3 radians. I just take that 2.3, I multiply it by 180 degrees and divide it by pi. Now here, again, I don't have any pi's to cancel, so I'm going to get probably kind of a messy answer, and I would just use my calculator, and I get about 131.8 degrees. So we can convert over. Usually, if you start with a decimal, it's okay to end with a decimal. Typically, if we start with a pi, we probably want our answer in fraction form or something like that. You'll notice that with radians, we tend to like fraction form a lot rather than decimals if possible. Here, it's kind of too messy to leave the pi in the denominator. But again, normally, if we can have some sort of decimal answer, some sort of fraction answer, that's preferred over the decimal answer. So you'll notice that as well.